All right, so just to recap, we had started talking about significant digits. I think the most important is to look at the rules for when digits are not significant. So in this case, if you have a decimal and you have a 0 to the left of the decimal, so it's like 0 point something, and then you have zeros before any other non-zero number, those zeros are just placeholders and do not count as significant digits. Okay, so 0.22 and 0.00022 both have only 2 significant digits. The other rule is like this. Again, these zeros are placeholders. So in this case, you don't have a decimal. Right? There's no decimals, and all these zeros to the right of non-zero digits are placeholders. Right? They do not count unless you had a number after them. Like if this was 98,000,001, then they would count. All right. So let's just look at the handout. We had some questions. This is question number 4. I'm going to go over some of them. And all we're going to do is say how many significant digits there are in each number. So in this one, we have 3. They're all non-zero digits, and non-zero digits count. So this one has 3 significant digits. This one, again, all non-zero. So it has 4. This one is like the one we just talked about. All these zeros are placeholders and they don't count. So this is just 1, 2, 3 significant digits. To recap this rule, if you have a 0 in between 2 non-zero numbers, they count. So this one actually has 1, 2, 3, 4, 5 significant digits. Right? This 0 does not count. Okay, so this only has 1. Okay, and I want you to try the rest, so I'm just going to pause the video. Alright, so question 5 says express the following measured quantities in scientific notation with the correct number of significant digits. Now the great thing about scientific notation is every digit is significant in scientific notation. So in this case, we have 4 significant digits. But remember, scientific notation says you have 1 digit and then a decimal. So we need to write this as 8.657. And then multiply that, my pencil just broke, multiply that by a factor of 10. Figure out the factor of 10, we're just going to take the decimal place and count how many times we move it. So if we move it to the left twice, it's times 10 to the power of 2. Now for part B, there's no decimal point here. And because there's no decimal, these are placeholders, so they do not count as significant digits. So we're only going to write it scientific notation as 3.5, not 3.5000. Okay, so multiply it by our factor of 10, and we move it the decimal over 1, 2, 3, 4 spaces. Okay, this one again, right? We have a decimal. When you have a decimal, the zeros after your after your non-zero digit count, but the zeros before it do not count. So this 0 and that 0 don't count. So we actually only have the 1 significant digit, 5. And we multiply that by 10 to the power. In this case, we're moving it to the right 2 spaces, so it becomes a negative 2. All right, so take a minute and try D and E for yourself. All right, so next is rules for rounding. And, well, when we round something, the first rule is when the first digit is to be dropped if it's 4 or less. Right? So, for example, 3.141. Right? If you're rounding to 4 digits, the 5th digit is a 3, so that's a 4 or less. And so this one just remains as 1. If it's a 5 or more, you're going to round up to 2. That's just basic rounding. Sure, everyone's okay with that. We're not going to go into the very specific rules because I don't care too much about rounding. But what I do want to go over is adding and subtraction. So the important thing is when you're making calculations, after you make those calculations, what do you round to? Like how many digits do you round to? And there's two rules, one for adding and subtracting and one for multiplying and dividing. When you're adding and subtracting, you count how many decimal place each number has. So here, for example, we're adding three numbers. This number has 1 decimal digit. This number has 2 decimal digits, and this number has 3 decimal digits. So when you punch it into your calculator, you get this. But you don't need to state every single number your calculator gives you. You're going to round it. And if these are measured quantities and you add them all together, we usually say your answer is only as good as is only as accurate as your least accurate measurement, which would be this one. So that means your answer should only have 1 decimal place. So in this case, you're going to round to 1 decimal place. And since the number after that 1 decimal place is 0, we just leave this one as a 1. We don't round it up. Okay, the rule for multiplying and dividing isn't the number of digits you have after the decimal, but it's the number of significant digits you have. So let's look at this example. We're multiplying two numbers. This one has 3 significant digits, and this one has 4. We don't count that 0, it's our placeholder. But out of the two, again, you're looking for the weakest link. And the weakest link is this one. It has the least number of significant digits. So your answer should only have 3 significant digits. When you punch it onto your calculator, you get this, but you need to round it to 3 significant digits. Right? Since the digit after is a 6, we are going to round the previous one up to an 8. So those are our two rules. Adding and subtracting, you count the number of digits after the decimal point, and for multiplying and dividing, we count the number of significant digits, and we always take the weakest link. So let's try a question back here. We'll look at question 6. Question 6 says, perform the following operations and round your answers accordingly. And you can use a calculator if you like. So the first one, if you just punch in all the numbers on your calculator, you would get 1039.67. But we're not going to use that many digits. Right? Since we're adding, we need to count how many digits are after the decimal point. This has 1, this has none, and this has 2. So this one here is our weakest link. So that means our final answer should be the same as that, which is no digits after the decimal. So these need to go away. But since that number is 5 or above, we need to round up the previous number. So this becomes 10. Instead of 39, we round up to 40. Okay, taking a look at, let's try D. D, we're multiplying. So when we're multiplying, if you punch it on your calculator, you get 109.72. But what are we going to round that to? For multiplying or dividing, you need to count significant digits. This has 2, and this has 3. So this one's your weakest link. So our answer should only have 2 significant digits. Now here's the tricky part. How do you write this with 2 significant digits? You can't just cross out these 3 because it becomes 10. But 10 is nowhere near 109. So you would think you'd want to round to 110. The easiest thing to do is to write it in scientific notation and write 1.1 times 10 to the 2. And so now that still says 110, but in scientific notation, every digit is significant and we only have 2. Okay, now on a test or something, I'm not going to be too picky about significant digits. As long as you're within about one significant digit, I'm fine. Right? So for this one, if you wrote 1040, great. If you wrote 1039.7, I'm okay. But you shouldn't be writing 2, 3, 4 more digits than you need. Right? I just want you to learn that you shouldn't be writing every single digit your calculator gives you. All right, I'm just going to pause there and check for questions. Question 7 is an actual practical example. So here it says, find the perimeter of a rectangular carpet that has the width and length of 3.56 meters and 4.5 meters. So remember, these are measurements. Somebody measured the carpet. And obviously it looks like they used different measuring devices, because this person who measured the width was a little bit more accurate than this person. Remember, when you're measuring something, you're always guessing the last digit. If you have a ruler and you're measuring something, it looks like something is somewhere in between the 5 and the 6, then maybe you say 5.5 or 5.4. That 4, you're really guessing. Okay? So this is a more accurate measurement than this. Okay? So in this case, we're finding the perimeter. To find the perimeter, we need to add all sides. So we're going to do twice the length plus twice the width. Okay? Since we're adding, we care about the number of decimal places. So this has 2 decimal places, this has 1. So our answer should only be as good as the least accurate one. So our answer should only have 1 decimal place. We don't need to worry about the fact that this is 2 times L, because that 2 is an exact number. So it has an infinite number of significant digits. It's an exact one. So let's write 2 times the length, which is 4.5 meters, plus 2 times the width, which is 3.56. And when you do that, you get 16.12 meters. But again, we're going to round to only 1 decimal place, so we're going to round that to 16.1 meters. Okay, for part B, we have find the area of a rectangle. So now we want to do area. So area is a multiplication. It's length times width. And so when we're doing a multiplication, we want to look at the number of significant digits. So this has 2 significant digits, and this also has 2 significant digits. So our answer should have 2 significant digits. When we do 4.5 meters times 7.5 meters, we'll get 33.75 meters squared. But then again, we need to round to 2 significant digits, so we're going to write it as 34 meters squared. Okay. Part C is a triangle, and it says calculate the area of the triangle. And we have the formula. Remember that 1/2 is an exact number, so it has an infinite number of significant digits. So I want you to try part C on your own. I'll pause the video and let me know if you need help. Alright, so the last thing that I want to talk about is the difference between accuracy and precision, because a lot of people use them, those words interchangeably. So I have an image here on the next slide that I use to sort of help. So here we have 3 targets for dartboards or archery. I do archery, so I like to think of it as archery. I suck at darts. But this is actually a dartboard though. So player A seems to be a really good player. They're getting all their darts right near the center. Now player B is getting all their darts away from the center, but still in the same spot. Player C is missing the center and getting them all over the place. So player A is both accurate and precise. Player B is not accurate because they didn't hit the pinpoint in the middle. But they're very precise because all of their shots are very close to their other shots. And player C is just neither accurate nor precise. Okay, now when we do an experiment, we have two ways of measuring error. It depends what you're measuring error. Are you measuring error to some sort of theoretical accepted value, or are you measuring the difference between your measured value and, say, someone else's measured value? Okay, if you're measuring error to some theoretical value, we call this percentage error. And this is the equation we use to solve for it. Okay, your measured value minus that accepted value divided by the accepted times 100%. And we have those absolute value signs there just because we don't want a negative number there. We're not going to have a negative percentage. Now, if you're comparing your measured value to someone else's, again, in the numerator, you find the difference between those two measured values, and you do the absolute value, so it's positive. And then you divide by the average of those two values. So you're looking for the midpoint, really, and then multiplying it by 100%. So we're going to try two questions here. First, question 8. And then question 9. Just go to the document camera again. So for question 8, I already have this done, but let's look through it. It says at a certain location, the acceleration due to gravity is 9.81 meters per second squared. And we'll talk about that number later in this course, but for right now, this is the accepted or theoretical value of the acceleration due to gravity. So 9.81. Calculate the percentage error of the following experimental values. So we have two people that make measurements, and we want to know how far off they were from that theoretical value. So to do that for person A, we take their number, 8.94, subtract it by that accepted value. Absolute value, so absolute value just gets rid of the negative sign. So without it, it would have been minus 0.87, but with the absolute value, we just get rid of the negative. And then divide by that theoretical value. And we get 8.87%. We can do the same thing with 9.95 instead of 8.94, and we get 1.43%. Then, if we were to actually compare those two students' values, so basically, how far off is this measurement from this measurement? Okay, so to do that, you find the difference of those two measurements. Again, keep it as a positive number, and then you divide it by the average of those two measurements and multiply it by 100%. So you find out one measurement is 10.7% off from the other measurement. Right? And that'll be it for our math skills lesson.